So now that we know that the limit as x goes to 0 of sine x over x is equal to 1, then we can solve several other problems. For one thing, if we had sine 3x over 3x, then that would also go to 1, because essentially just the argument and the denominator are going to 0 at the same rate. So it's just like sine x over x. I mean, one way that we could even express that if we wanted to is we could do what's called a variable replacement and say, okay, let's call y equals 3x and substitute this throughout. So now we're talking about y, sine y over y as, well, as x goes to 0, y also goes to 0. So in fact, we're looking at this, which is clearly the limit as y goes to 0 of sine y over y is equal to 1. So, so indeed, the limit here is equal to 1. Now, or here in the notes, I call it u rather than y, but it doesn't matter. In any case, now, if we didn't have the 3 on bottom, we could just force it in by multiplying by 3 over 3 so that we are effectively just multiplying by 1, and that does not change the value. But we can now, having the 3 involved, we can rearrange it, move this 3 inside, and leave the numerator 3 outside. This part definitely goes to 1, and this part is left over, so the limit is equal to 3. Now, for a much more tricky example of how we could use this, we can also figure out the limit as x goes to 0 of cos x minus 1 over x. Notice that this is discontinuous and has the form 0 over 0, as we sometimes say. The top goes to 0 and the bottom goes to 0, so you need some kind of sophisticated method to figure out what this limit is. And so we surprise, surprise, use the conjugate, right? The conjugate yet again comes up. Now, it's not obvious why the conjugate would play a good role here, but after multiplying by the conjugate, we get cos squared minus 1, which, if you remember your trig identities, is the same as sine squared. Or in fact, I think maybe I'm leaving off a negative, am I? Yes, I'm leaving off a negative. So this should be negative sine squared. But it doesn't matter because the end is going to come out to be 0, so even forgetting the negative, I still get the right answer by a little bit of an accident. But in any case, now that I have sine squared, just imagine there's a negative on the outside of this and it'll be fine. I split off, right? I split one of the signs with the x part on bottom here, and I split the other sign together with cos x plus 1. Now, this part of it where I have sine x over x, that, again, goes to 1. This is continuous, and you can just plug in 0 and get out 0. So it's 1 times 0, which is equal to 0. So those are all of the theorems that we'll discuss for now. Later on, we'll discuss L'Hopital's rule, but we need to first talk about derivatives before we can do that. So exercises in the next video.